Alright, so I am going to be doing the standard for circuits. As you can see here, I have two. So, the example I'm going to be doing today is this one here. And we're given that 16 amps is going to be flowing down this way, and because of that we know 16 amps is going to be, of course, going all the way around here and then up through here. So because of that, we can already determine that 16 amps is going to be going right here. And so now we just need to figure out what is going on in this area here. So we have a 84 volt battery and then a 4 ohm resistor. So we know that there's going to be 16 amps coming in before this little break, going either way. And because of the 84 volt battery, we know that there's going to be an 84 volt difference between right here and over here. So because of that, we can look at this resistor here and know that there has to be some sort of I going down this way. So to find that, we can use V equals IR, which is going to be some I times 4. And that's going to have to equal 84. Right? So what we can just do is 84 times, 84 divided by 4, which is going to be 21. So we know that 21 amps is going to be going down that way. And then, of course, across this way. So with the 16 and the 21 going this way, we can then say that, let's see, 21 plus 16, it's going to be 37 amps going up this way, right? Okay. So next, what I'm going to do is to find the power provided and dissipated in all of the batteries and the resistors, because that's what was on the quiz. So let's see here. Well, we know that this battery since it's lower than this one here, is going to be getting charged by this other battery. So what we can do is take the 60 volts and multiply that by the 16 amps to find the power, or the wattage, that it's going to be putting out. So that is going to be 16 times 60, which is going to be negative 960 watts. Okay, so negative 960 watts. Wow, that was interesting. 60. Anyway, and then the second, this battery here is going to be providing 72 times 16, which is going to be 1,152 watts. Okay, and then this battery here is going to be 84 times the 37 amps that it has, which is going to be Oops, 84 times 37, which is going to be 3,108 watts. So that is going to be the power provided, right? So now what we need to do is find where all this is being dissipated. So let's see. Well, looking at this first resistor here, we know that power equals it's a really big P. Power equals I squared R. So we can just look at each of these resistors and what the current is there and figure out how much power is being dissipated there. So at this first resistor here, we see that it's just 16 amps and a 1 ohm resistor. So 16 amps squared, so 16 squared and then just times 1 is going to be 256 256 watts. So 256 is our first one. Oh, don't know what just happened there. Shrunk our picture. Okay. Anyway, 256, right? So that's the first one. Then the second resistor, let's do this one. So it's just going to be 16 squared, again, because it's still 16 amps through here. 16 squared times 2 this time, since it's a 2 ohm resistor, which is going to be 512. 512 right there. And then this next resistor is going to be 16 squared times 3, which is going to be 768. I'm not going to write that down this time, but I have it on my calculator. And then the final resistor here is going to be 21 squared times 4, because there's 21 amps going through that resistor. So 21 squared times 4, which is going to be 1,764. So if you take these 3 and then those 4, they should equal the same thing. And there we go. That should do it.